Alright, welcome to my video. This one is about VLSM, Variable Length Subnet Masking, the most efficient subnetting possible. Now, highly customizable is VLSM, and that's why Cisco came up with it. In this scenario, you have 3 locations. One location here, the biggest, is in Arizona. You have 60 nodes. The requirement is 60 nodes. Here in California, you have 20 nodes. New York, also 20 nodes. And the IP that was given to you is 192.168.1.0/24. And you have to make it work. You have to provide enough IPs for these networks. All the required networks. Let's not forget our WAN links. Those are easy to forget. You always start with the largest network first. Okay, and that's going to be down here in Arizona. 60 nodes. So you need to figure out what subnet mask is going to allow you to get the 60 nodes. So you remember that in subnetting, zeros are host, represent host, okay, and ones represent networks. After you convert the subnet mask into binary, then you'll know what you have to work with. So that's the first step, is to convert your decimal representation of the subnet mask into binary. And for that you need your binary chart. Okay, now it is possible to do subnetting in your head easily using this magic number system, where you take your interesting octet. In this case it's 192, you subtract it from 256, and that gives you the increment of 64. Okay, 64 satisfies the requirement of 60 nodes. So that's what I did, that's what I used. And my range for this network is 192.168.1.0 through .63. 0 would be my network ID. It cannot be assigned to any hosts. 63 is my broadcast ID. Excellent. Then I went ahead, took the liberty of this scenario is by no means complete, but I did assign the IP address to router 3, 192.168.1.1. Okay, that's going to be the default gateway for all the devices in this network here. And then I took this server, which I'm going to pretend that it's running several things, like domain controller, Active Directory domain controller. It's also running ISA server, which is a firewall product from Microsoft, which they don't recommend that you do that. They want you to run ISA server on its own. So I'm going to write that in there, ISA server domain controller, and the IP address is 192.168.1.2. ISA server also, if I'm not mistaken, I'm not terribly familiar, can do spam filtering, which everybody needs spam filtering. There's just so much spam out there. I just noticed my link went down between this router and this switch, and I don't know why. For some reason the port is off, so I'll turn that back on. This is also off somehow. I'm pretty sure I'm using Giga Ethernet 01. I have problems on this network. Also, I have a problem here. What's going on here? I'll turn this link on, see what happens. I should be competent in doing this in the Cisco iOS, which I am not. But I need to practice. Okay, that did not work. Let me turn on this interface. That did not work. How about this interface? For security purposes, you gotta be careful. I'm turning stuff on and off. I mean, if something needs to be off for security reasons, and you temporarily turn it back on for troubleshooting, guess what? You need to go back and turn it off. Because hackers go out from their bedrooms every night and they wiggle on doorknobs to see what's open. There. Everything is green again. So what interface do I need to turn off? I'm going to turn off 2. Oh, that's what I was using, so that was not right. I'll turn that back on. I'm going to turn off 01 and 00. Excellent. Interfaces are off. Here, I think it's going to be the same thing. I think I'm using 2. Yes, using 2, so I'm going to turn off 01. What about on this side? They're both on. Both my gigabit Ethernets are on. Interesting. The link is down. And I don't know why, so I'm going to get rid of this link. Oh, there it goes. Okay, we're green again. I'm going to save this. So where was I? Yes, with variable length subnetting, you always want to start with the largest address. The largest network first. So that was Arizona. Now let's move to California. California has a requirement of 20 nodes. Okay, not 20 employees, not 20 team members, because we all know that many times you'll have more computers than you do employees, because you got to figure your servers and other devices. Sometimes you have less computers than employees. People share. But anyway, we have a requirement of 20 nodes here in California, and we're going to pick up where Arizona left off as far as the range. We have 192.168.1.64 through 95. Okay, this is what I figured for California. Why 64 through 95? Because Arizona left off at 6.3. Now, New York, I figured 192.168.1.96 through 127. Okay. Why 96? Because this is where California left off. 95/27. Now we gotta set up networks for the WAN links. Can't forget the LAN links. And if it weren't for VLSM, this IP address, we could not satisfy the requirements of this scenario. So VLSM saved the day here. Of course, there's not much room for growth. If one of these locations were to experience a sharp rise in growth, a hiring spree or something, then we'd want to figure something out completely different. But let's look at this link here. This WAN link is you need an IP for each interface, okay? In this case, we have serial connections. Okay. And this serial connection, this side here, I see the little clock there, so that represents the DCE. On this other side is the DTE. But if these were actual WAN links, we're simulating a WAN link at the moment with this serial connection, you would have to assign an IP to each interface. So I came up with this network: 192.168.1.132 through 35. Now this WAN link, .136 through .138, that provides 2 IP addresses for this WAN link. Okay. Now, my last LAN link, 128 through 131. Okay, if you notice, this 128 picks up where New York left off. So that's just the way I chose to do it. I went from assigning this range to New York, then I came over to this WAN link over here between California and Arizona. The two have nothing to do with each other, it's just the way I did it. So there you go. You have 2 IP addresses for these 2 interfaces, these 2 routers, 2911 routers, which are medium duty routers, I assume. Well, I'm on a journey. I'm on a journey to learn this stuff and to get certified. Thanks for watching my video. I hope it was informative. Okay, I'm coming back to this video because I noticed I made a mistake. There are probably other mistakes on this scenario, but what I noticed is that I needed to add one more IP to this WAN link, 136.139. Okay, there are 4 IPs here, but only 2 are available to assign to each interface. Okay, because 136 is the network ID, 139 is the broadcast ID. So in the previous video, I believe I had 138, which was incorrect.